Welcome to the R Help session. Today we're going to be reviewing some R basics for those of you who have not had R coursework before, as well as reviewing the R code necessary for your first homework assignment, and then we'll be taking some questions. So, go ahead and open R Studio. It will look like this, probably more like that. So, the first thing you'll want to do anytime you're using R is to open a script so you can save all the codes and commands that you use. It also helps everything stay organized, and then you can come back and whether later today or later in the course or later in life, when you open it, you'll have everything you need. So I'm going to open a pre-made script. If you don't have one pre-made like I do, go ahead and hit this nifty little button right here, and you can open a new R script. Okay. Just make sure we're recording here. Great. So, R code. I'm going to enlarge the font a little bit for those in the classroom so you can see that more easily. First and foremost, anything with this pound sign, or is basically we now call it a hashtag, is a comment. All right, it doesn't run as code, but you can use that to comment on what you're doing. You'll see this very common, probably the most common technique, and is used to organize code and to give titles and headings, or just in homework to mark, this is question 1, this is question 2. Makes it very convenient when you need to go back and look at things, or especially for us, when you go and ask your TA a question, you're looking through your code to see what you're doing. If it's organized, it's simpler. My second suggestion, please keep your R code in a script. First off, we ask you to submit your script with homework periodically. That's mostly so that you get into this habit of saving your code. Because if you don't save your code, then it's really hard to go back and figure out exactly what you did on any given problem. Did you have a question? No, okay. Sorry. Hey. All right, so when you have something in a script, I've seen people take it from their script, copy it, and then paste it into the console. It's a little easier to, let's say I just want to run the number 12. Instead of typing 12 in here, it's easier to run it from the script. There's a little button up here that says run. Or I think it's even easier to use the keyboard shortcut. On a Mac, it's just Command Enter. On Windows, it's Control R, R for run. Similarly, I believe Control Enter works. So if someone with a Windows computer wants to verify that for me, that'd be great. But let's actually talk about some code as opposed to how to use it. Okay, next section right here. R has a few different data object types. One is just a value. In this case, I'm going to create an object called value and set it equal to 12. You see it pops up here in your environment, value, and it is just 12. All right. If I give the name value to my prompt, it comes out and just says value. If I want to create a vector, that's the all-important C function. It combines numbers or words or whatever together into a vector. Here's my numeric vector. It's got 4 entries, 1, 3, 5, 7. All right, and then here, type in my vector, and it comes out again. Similarly, I can create a matrix. So I'm then taking the entries of my vector and putting it across a 2x2 matrix, which looks just like that. Okay, here's the 2x2 matrix. Pretty straightforward. You may have noticed that when I name these objects, I can call it basically whatever I want. You can't use spaces in your names of things in R, so instead of spaces, try periods or underscores. Some programming languages have periods and underscores mean important things. They do not mean anything other than naming conventions in R. Okay, any questions? Expand this a little bit. That's how to save objects under different names and different types of objects. Just new numbers, vectors, and matrices. Some common, oh, sorry, someone's still transposing that. So, common functions that you'll be using frequently. There's the mean function, which is how to take the average of a vector. So average of 1, 3, 5, and 7 is 4. You can find the sample standard deviation with SD. You can add them together with the sum function. You can multiply them together with the prod function, so product, right? Basically, any simple mathematical operation has a named function in R. It also works just as a calculator. You can go 1 plus 1, 1 minus 1, 1 times 2, 1 divided by 2. Gives you all of that. Okay. Some more challenging functions that come from pre-cal classes. We have natural logs, which are sometimes helpful. Square roots. Exponentiate, which is just the inverse function of a natural log. You have e to the power of something. Pretty important in financial calculations. If you need to just square something or cube something or give it an exponent, that's done with the caret or the caret symbol on your keyboard. Shift 6. And the absolute value function, which just turns negative numbers positive. Right? Any questions on doing using R as a calculator? Yeah. I am. Correct. I'm not bothering to go up and click the run button every time I'm using the keyboard shortcut. So once again, the keyboard shortcut on Mac is Command Enter. On Windows, it's Control R or perhaps Control Enter. Yes, ma'am.
Is there any time when you need to use spaces, or is there any time spaces will mess you up?
Spaces are, so for recording purposes, her question is, when do you need to use spaces? Spacing is just for visual convenience. You notice here, I have spaces here on either side of the equal sign. Doesn't mean anything. It just is nicer to look at, in my opinion. And I didn't even think about that when typing. It's just a habit now. But yeah, you can just, spaces are just for visual, and if you're putting them inside certain names of functions, will actually hurt you because it doesn't know how to run a space. Okay.
What about spaces around an equal sign? Notice that they'll use a space before an equal sign and after.
That's fine, because it takes object name that it can process, moves over to the next statement. The challenge with the space is if I type in, hello world, A, hello is not an object, B, it's trying to make the world into something else. Unexpected symbol in hello world, that unexpected symbol is a space. But if I give it a correct object name, like my vector, I'm going to space, operator, and then the next thing. So when in doubt, I guess don't use spaces. You can put them around equal signs, you can put them around plus, minus, multiply. Actually never thought about when to or not to. It's just become kind of default. So I guess to keep it simple, don't use spaces. Probably a better answer, more eloquent answer than that, but that's a great question. Thank you. So we can use calculators with just the calculator app on your computer, but we probably are more interested in pulling in data. So on your homework, you've got data that's inside the car package. Now, a package is an additional library or set of functions and data sets that you can pull into R from R repositories online. And that's really quite simple. You just type, as you've probably hopefully seen the message on Canvas say, there's an install.packages function. It'll go find the car package and download it into your R program for you. All right, but once you download it, it is not activated. To activate it, use the library command, and it brings the car library into your current R session. Okay? Now, a shortcut for that in our studio is to click on the Packages tab over here. And you can scroll down to Car, which is not about cars. As you can see here, it's a companion to applied regression. So you can check the box, and that does the same thing. So if I wanted to load the Coda package here, I can just click Coda, and it would take care of that too. the two ways to do the same thing. You only need one of them. For future replication purposes, to make this replicable, I would use the code in your script. So we've got a data set called UN that's inside the car data set, or that's inside the car package, excuse me. We can view the whole thing if you type in UN, but it's huge. It's not that big, it's only as long as many countries. But a good habit to get into is to, when you're looking at a data set, is to view the first few lines only. So there's a function called head, shows you the header of the UN data set. So here's the first 6 lines of UN. We've got some of the countries that start with A, we've got an amount of infant mortality, and we've got a GDP of that country. If you are interested in seeing the whole thing here, you can just run UN.
Where did you say that download was at?
For the package.
Yeah.
You just type the code into R, it takes care of the rest for you. Now, is it asking you for a crayon mirror? Or what? Did you run this? Did you run the line install packages?
I did.
You did that? Okay. Then you try library car.
I did.
All right. And is the UN set available?
What would that be?
So you can see it if you want to visualize it. Well, it's not active until you call upon it. So if you type in head of UN or just UN itself. So here I type in UN and it gives up all these UN countries. Just too many to see on the screen at once. That's why I suggest just look at the header. Is that working for you? Now it's showing? Great. Any other questions? Yeah, not working for anybody? Yes, please.
I like already existing in all of that.
Great.
But it's saying now, if I'm trying to do it on this session, and it's saying that it's not available to have a script. It's unable to access the next repository. Like I have it here.
Okay. You only have to install a package once. Once you install it, it's downloaded everything it needs from the internet onto your computer. But every time you open R, you'll need to load the library again. So 2 separate statements. One is install, and one is to load. Okay? The reason being, if your R program loaded all of your packages every time, it would move a little slower than you want. So they offload them every time before you quit. Okay? Everybody get the UN data set okay? If you have not, let us know. It's important for moving forward. Really important for doing your homework. Right? All right, so we said this data set is big, but just how big is it? You can find the dimensions of a data set, meaning the number of rows and columns, using the dim function. So there's 207 rows and 2 columns. Okay? So if you're looking at this same data set in Excel, you actually have 3 columns because you have the names down a column. And here there's just names. They're not included in the actual data. And you have 2 rows, 2 columns of numbers. So that's the 2 here, 2 columns, and 207 rows. So we have 207 countries, and we're measuring 2 things per country. Fair enough? So it gives us an infant mortality and a GDP. What does infant mortality measure? What kind of GDP are they measuring? It's kind of a rhetorical question because that's our next point. If you have a question about any object or function in R, you can use the question mark to pull up a help page. So I'm going to type question mark UN. And right here in the window, we can expand this to make it a little bigger, is the information, or the what we call a documentation page on the UN data set. So like we said, it's got 207 rows and 2 columns. Data is from 1998 from the United Nations, all over the world. There's some data missing. All right, so we'll talk about missing data in just a second. First off, you can scroll down and you can see what is infant mortality. Specifically, it's the number of infant deaths per 1,000 live births. Yes? Okay, you're fine. All right, and then GDP is GDP per capita in US dollars. All right, so if you ever have our data set, now no, it has to be a built-in data set. You just download it from the internet. It's not necessarily going to have explanations with it. But this defines exactly what these variables are, because you really can't see that just from the name, right? Cool? We can also use this question mark approach with any function. So like if we want to know something about the mean, it's question mark mean. Here's the page on the arithmetic mean. Arithmetic meaning you add stuff up and divide by the number you have. So the standard average, right? Well, for our mean function, we actually have a few arguments that you can put in. You can put in just the data, which is x. There's a trim option, which we're not going to worry about. There's also an na.rm option. So an na in R is a missing value. Na meaning like not applicable, right? If we look back at the header of our UN data set right here, we have some NAs. So the country of Andorra doesn't have an infant mortality, nor does it have a GDP measurement. American Samoa doesn't have a GDP measurement. Okay? The trouble is, if we wanted to take the mean of GDPs for UN countries, some of those are empty. And if you just put in a blank in an average, it's not going to be able to compute. You need to make a decision. Do you want to drop it or do something else? Dropping it's the most common thing, and you can tell your mean function to do that by saying na.rm equals true instead of false. All right? You ever tried taking a mean of a set of numbers and not know what some of those numbers are? It doesn't work. It would come back and say NA. So, if you and I right now wrote out a set of numbers by hand, and I didn't give you some of them, but told you to take the average without knowing it, you wouldn't know the average. So that's what the computer's saying too.
When would you ever put false?
If you're not supposed to have missing values, so later on, if you're writing a program, you're not supposed to have missing values. This will come out and say there's an error, basically. Something else wrong happened in the program. So good point, because usually you want to actually get at the average. So note here that the head, the top of the function description in the documentation says false. So na.rm, rm meaning remove, right? So remove NAs is false. That's the default. Whatever it says up here is the default. You can change it to true, and it will remove your values for you. We'll do an example in a little bit. Okay. That's a little abstract, but hopefully when you see this and then try your homework, rubber hit the road, and you'll be able to see how to use these pieces. All right, so a last couple things. 371's big focus is on regression. So let's briefly recap how to run a regression model in R. The regression function is LM. LM stands for linear model. And inside of LM, you give it your y variable, tilde your x variable. All right, so this is called a tilde. So I want to model infant mortality based off GDP. So I'm going to get an equation back that says predicted infant mortality equals an intercept plus a slope times the GDP. Right? Y equals mx plus b. And this function does remove the NAs by default. So I ran this here, and I saved it all as model. Now if I want to see what the model is, it gives me my intercept and my slope on the GDP. But if you recall from 309 or whatever stats class you took before, you most likely covered that there's more to regression than that. So let's type in summary of the model to get all the information out. All right. here we have the same estimates that we saw before. We also see their standard errors, their t-statistics, and the p-values associated with those t-statistics. Down here we also have the r-squared. And if you recall, we briefly in 309 discussed an f-statistic that has a p-value for the whole model to see if the model is worth anything at all. All right. So you don't have to know each of these pieces just yet, but if you have learned them before, that's where to find them for now. Yes?
Is the little squiggly just saying that those are your two, like, the
The squiggly separates the y variable from the x.
Okay. So if you,
Y tilde x, y squiggle x.
is there any situation where you're gonna like maybe use more than one of those, like where you have
There are situations where you'll have multiple x's. So if I had other data right here, you'll never use multiple tildes. Only one of those because you have the y's on the left and the x's on the right. But there might be a chance where I want to add something here to say, what's the size of the country? We don't have the data right now. For example, what's the latitude of the country? Maybe you have a variable called continent. For some spatial awareness type stuff. When we start multiple regression, you'll add them together with just plus signs at the end of the model there. Okay. Great question. So in review, just from the top here, please write comments on your code. Use a hashtag # there to comment something out, so then R won't run it as code, because if you just write words, it'll not know what to do and throw you errors. You can use that to organize your homework, like I've organized the presentation here. We have values, we have vectors, we have matrices. They're just growing in dimensions, right? We can use R like a standard calculator. We can load data and packages, right? So we install a package, and then every time with R we need to load it separately. If you have large data sets, view the top first. And if you have questions about things, you can use the question mark. All right? The other fantastic tool to learn as you're getting used to R is a thing called Google. I say that with a hint of jest, but if let's say I wanted to take an average in R, and I didn't know that the function was called mean, right? Because if you type in average, that's not going to get you very far. Average isn't a thing. But if I go to Google and I type in how to take the average in R, the very first hit is the mean function. All right. Similarly, if you want to find the residuals from your regression model, you can also just Google that, and the first or second hit will be exactly what you need. It's pretty cool. I guess I should say it's not necessarily Google that's pretty cool in this case. It's the sheer number of people who have written blog posts and guides and editorials on how to find the right R code to use. There's a lot out there. Now, that's not saying you can't come and ask us, but that is giving you another tool in your toolbox. And lastly, we have the LM function for doing regression logs. I know I've gone through this kind of quick. I hope now we can have a valuable Q&A session. And if you have specific questions on your homework or things you're trying to work on, we can take those questions now too. But I wanted to review these to get that information out there so that we can address that momentarily. Okay? Fair enough? Yes, please.
Can you go over the kind of different formulas or like organization for like box plot, histogram?
Plotting. I knew I forgot something. That would be really good to do, wouldn't it? All right. So, shoot from the hip here. Oftentimes when I'm making a whole new section in my code, I put a 3x3 block of pound signs so that it's very visually disruptive, so you can see that there's a new section. Plots and graphics. Great question. All right, so let's use our UN data here. It's called UN, not US. Let's say I want to make a histogram. I'm going to space this down so you can see it from the top here. All right?
What does the $sign do?
Oh, good question. Another thing I missed. So in our data set UN, we've got a few different attributes. We've got rows and columns, right? And the columns of our data set represent different variables, and then the rows are always different observations of those variables, like Afghanistan. If I want the infant mortality column, I can use the $sign to pull out the infant mortality variable from the UN data set. So now if I run this, I just have a string of numbers. Right? This is the infant mortality column, which is now just a vector. I've taken it out of the matrix. Yep. It identifies a variable within a data set. Make that distinction because if later on you're using matrices that have unnamed columns, it won't do you much good. It's only when you have named columns or variables in a data set that's how it's useful, which is most of the vast majority of the time. So I should probably not even mention it. You won't encounter it for a while, but yeah, it pulls a column out of the data set. Similarly, I can pull out the GDP column. The GDPs. So why do I want to do that? I want to do that because I can't create a histogram of the whole data set, but I can create a histogram of just GDP. So I'm going to ask for the histogram of the GDPs, and the default looks like this. Okay. As you can see, and might have expected, it's heavily right skewed. If I want to see infant mortality, I can also ask for the histogram, just HIST, hist, of infant mortality. Okay. Or if we want a box plot, the function for that is box plot. Yes, please.
How do you decide on the bin size histograms?
Good question. The hist function in R has a formula that it tries to calculate the bin size for you. If you're trying to create your own bins, there's a couple different ways to do that. The first way, so let's go back to the GDP one here, is you can specify the number of breaks that you want in the data. So this is a breaks option. So let's say this is about 10 bins. It's probably like 9. Yeah, it's 9 bins. But let's say I wanted 20 breaks. So that's a box plot. Excuse me. I may not get exactly 20 because maybe 18, 19, 20, 21. But now I've got about 20 breaks in between my bins. Okay, so it's halved the bit. Yes. Breaks means the number of breakpoints. So if I was to just to say one break, it would have 2 columns. Once again, that's the darn box plot. 1 second. Well, it doesn't know how to do that. But yeah, essentially it means the number of bars you'll have. If you want to get really specific, you can give it your own breakpoints. So let's say I wanted to break it 500, 5,000, 10,000, and 30,000. This is not something I often do, and as you can see, it's not letting me do it right now. Oh, you'll want to give it the endpoints too. So I'm going to give it the endpoints so it knows how to finish. And now I've got bins of different widths at the exact specified values that I gave it. Not usually something you'll have to do, but in case you want to, there's how to do it. Okay. For posterity's sake, I'll show the different variations there. Any other questions on histograms? Now you can change axis labels, you can change colors, you can change the titles, there's a lot of customization you can do, but that's all you need to know.
What other ways can you use the
C function always just creates a vector. So in this case, I needed to give it a list of numbers, and I'm giving it to that as a vector. And it just goes through them one at a time. You can use it with words too, in case you ever need a vector of words, but that's not really all that common. For example, I can say male, female. Words work too. It's always just vectors. All right, a box plot, if you want one, is box plot. By default, it chooses, or it takes the median, the first and third quartiles, the min and the max. You may notice that's not actually the max. Limit on this box and whisker, the whisker on the box here is 1.5 times your IQR, which if you recall from 309 is a general way to start identifying outliers, all of which outliers are marked in circles. Okay. Let's say you wanted to get, well, there's different ways you can, do side-by-side box plots for variables that, match. So if I wanted, that's beyond the scope of today at least, but, you can get all of those things with the box plot function. So you want to do a scatter plot. After all, that's really what we're doing with regression. We're making a scatter plot and fitting a line to it. I'm going to plot the infant mortality against GDP. So in this case, I'm doing x, comma, y. Let me switch that around because in our example, GDP was x, right? Yeah, GDP is x and infant mortality is y. So now I go x, comma, y. I have GDP on the x-axis, infant mortality on the vertical axis, and circles for each of the points. Okay. Once again, this script will be posted for public consumption after the session. Any other plots you're interested in? Yes?
So why here do you use a comma instead of a squiggly?
Great question. That's the standard. If you want to use a squiggle, I think you can. Yep, you can do that too. The difference is this squiggle, or tilde, creates what we call a formula, which operates typically a little differently in a lot of functions than do just straight arguments. So in this case, an argument would be, just our x and our y. In this case, they operate the same. That's not always the case. Often, if you look up code, you'll find that the squiggle is used almost exclusively in models as the model formula. But yeah, they both work here. Yes?
How do side by side box?
Great question. We're going to need something to break down our box plots. So let's go find another data set to make our box plots work. Let's do this. So to create side-by-side box plots, you need a categorical variable as well, right? Because you're separating to two different categories and then measuring the same value within it, and that's why they're side-by-side. So for kicks, let's just take the UN data set. We're going to do the first half of the alphabet, A to L. That was weird. Sometimes it tries to autocomplete stuff for you, it's not always right. And then we'll do M to Z. Okay. Let's look at our UN data set here. We'll find where the break is. Between Macau and Luxembourg. Or better yet, how many columns do we have? 207. So let's do this. UN, the first half, just go first and second. First half is going to be the UN data set. And we're going to use some square braces. All right, these square braces allow us to choose certain rows and columns within the data set. We separate the rows and columns with a comma. Okay? First is rows, then columns. What rows do we want? Well, if we're going to take about half, we're going to go row 1 through 104. Let's go 103. Right? In this case, the colon tells R that we're going from 1 to 103 and every integer in between. We want all the columns, so we're going to leave the column space blank. And we'll do the same thing here from 104 to 207. All right, once again, I'm just doing this so that we have two separate groups. Otherwise, there's no reason to do side-by-side box plots. We could do a side-by-side box plot of GDP versus infant mortality rate, but those don't measure the same. The correct plot to look at those together would be a scatter plot. All right, now that we have that, let's go box plot, UN1, $sign GDP, and UN2, $sign GDP. Got to run the code first, Fisher. There we go. Okay. Side by side. Now, we talked about formulas earlier using the little squiggle, right? There's other ways to do side-by-side box plots, but we can talk about those when needed. Okay, questions go back to you. What else do you want? What else do you have questions about? Yes, please.
Can we use the subset function?
We can. If you'd really like to. I'm not an expert on the subset function. Instead of subsetting with the subset function, I personally prefer physically creating objects like this. That's my brief answer. If we really want to, I can give it an attempt. I know it's popular among some. So if you're not familiar, if you want to create a subset, there's a subset function. You can open the help page here. Which gives you some information. So really the important part is putting in the data you want and then telling it what subset to get. Okay? So for example, we could say, let's create a UN, what do we want to subset? Low birth rate or low mortality rate. We're going to subset the UN data. How are we going to subset it? We're going to only take where the UN infant mortality is less than, I don't know, what's your favorite number, 40? So maybe I made it sound a little too scary, but it works just fine. So now we have all the countries with an infant mortality less than 40, and that's 40 births, infant mortality births per 1,000. I say births. Less than 40 infants per 1,000 dying. So once again, so you plug in the dataset name, and then you tell it what criteria you want to base the next step on. Yes, sir.
How do you get the information to show up on the console after you've written the code? Mine doesn't show up.
How do you mean?
Like when I run something, it doesn't show up there.
Here in the console?
Yeah.
So if you just type 12, it doesn't come back with 12? Or for example, 2 plus 5 or something?
Well, when I type it in there, it does, but when I type it in my code, it doesn't come back here.
Okay, you have to run each line of code for it to move from the script to the console. So you can do that by clicking the run button or using a keyboard shortcut. Any other questions? Yes, please.
When you do the final thing with the name of the subset,
Yes.
and you use an equal sign, is that the same thing as doing the little arrow?
Yes. Oh, great question. So the original R programmers created this. Well, let me not call it UN.low. We already have that. So my favorite number. All right. So instead of an equal sign, you can use a little right-facing arrow, left-facing arrow. Right, my right hand right now. Left arrow. So this takes number 56 and it puts it into the favorite number. Equal sign does the exact same thing. Now, why are there two versions of the exact same thing? Because if you really wanted to, you could do the following. and assign it the other direction. So now we're putting 56 into favorite number the other way. If you get really into computer science, nitty-gritty, this is helpful because it shows you the direction of the assignment. We're putting 56 into favorite number, regardless of which line you look at. Usually we process things left to right, and so the equal sign makes just as much sense. But in case you were doing other applications, that's where the arrows come in. I say that because the original programmers of R used the arrows, and then future updates put the equal sign in. At least I'm pretty sure that's where it came from. I didn't read the history book on how people developed R. But it's just an equal sign. So you'll see that on lots of the help pages and perhaps your professor's code. But just remember that this is the exact same as that. Okay? Okay? Yes, sir.
Could you go over some like the homework questions on like basic probability? So I don't take through that here. So I don't
Okay. We certainly can. If anyone, this is specifically for our help with the programming. If that's everyone else is interested in doing that too, we certainly can. But we'll probably take our questions first. Unless everyone's more interested in talking about probability theory. All right, cool. Some probability theory. So that our watchers at home can see this too. I'm going to be typing it here. You really don't have to type most of this out unless you're actually doing calculations. So give me a question, for example. I don't remember them off the top of my head.
Well, could you just go over like what independent variables and like disjoint mean again?
Great question. All right, so independent variables. Test my typing skills here as I talk. The definition of an independent variable, defined. Probability. Now this won't run in R if you type it like this, but roll with me here. Two ways to look at this. So the probability of, well, let's start with the other one. They're independent if probability of A and B equals the probability of A times the probability of B. Okay? So if you take their marginal probabilities, probability of A times the probability of B, and multiply them, you get the joint probability of A and B. Disjoint A and B are disjoint events if they never happen together. All right, so the probabilistic way of stating this is probability of A given B is 0. All right, so the probability of A given not B how do I represent this with a keyboard? There we go. Is greater than or equal to 0. Now, if the probability of A given not B is 0, then the probability of A is just straight up 0. It doesn't happen. But yes. Okay. All right. Some probability rules you'll want to know. Conditional probability. probability of A given B, so that's what that vertical bar means. So this is saying we're in a world where we know B happens. Okay? And based off that, what does that change our understanding about A? Well, it changes it in the following way. Probability of A that A happens given B happens is the probability that A and B happen divided by the probability of B. Okay. We can twist this equation around and get Bayes' rule, which says that the probability of A given B is the probability of B given A times probability of A divided by probability of B. If you're really interested in how to derive that, take this for A given B and B given A and merge the two. Do a little algebra. Don't have to know that. What else? This rule probably has a name. I believe it's called the general additive rule. Based off my hesitation on knowing the full name, you don't have to necessarily know these names. But it basically says the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. Okay. The reason being, if we take all of A and we add all of B, we now have an overlap in the middle. If we don't deal with that overlap, then that overlap is double counted, so we take it away once. Is this helpful? Yes? Cool. A couple other things that might be good to know. Probability of A is equal to the probability of A given not B plus A, or probability of A given B. If you need the probability of an event and you only have two conditionals, well, there's only two things that can happen in this scenario. B could happen, or maybe it doesn't. So if we take both possible situations, add them together, we have all situations, and we don't have to worry about B anymore. Okay? Lastly, one of the most important of all, probability of not A is 1 minus the probability of A. So in this case, we're talking about discrete events. A happens or it does not. It is not a value yet. But you can take a value and make an event. For example, what's the someone being taller than 6 feet tall. Height is a measurement across a spectrum, but being taller than 6 feet is a yes or no. So let's say A is being taller than 6 feet tall, meaning not A is you're shorter than 6 feet tall. Okay. I list a few of these specifically because I remember them on your homework this week or next. You're welcome. Side note, this is equally as valid. Probability of A not happening, knowing that B does happen, is this 1 minus the probability of A happening, knowing B happens. Most of probability really is the same 3 or 4 rules, mushed together, turned around backwards, and reused in different scenarios. Any more questions? Feel free to head out when you need to. If you have individual questions, feel free to ask Han and I. We'll be here for the next few minutes.